So here we have 4 milliamps of output, and as I move out to the 1/2 meter, I get to my 20 milliamps of output. Welcome to SICK Sensor Secrets. Today we're going to look at analog output. Outputs could be analog in current or analog in voltage. So we can have a 4 to 20 milliamp output or 0 to 10. So you'll see that on a lot of data sheets. So real quick, we're going to take a look at how do I set one up. Now in a PLC, you're going to have an analog input card and there's all that. But just desk setup, like how would you test it? How would you work with it? So we have our wire colors. We have brown, blue, white, black, and gray. Very common standard cable colors for pretty much most factory automation companies, and we're making sensors. So what I have here is I have a DT80 analog output and IO-Link and a switching output as well sensor, and it's a laser, and I'm going to shoot this laser at another target, and I have it set up with a 4 to 20 milliamp, and I taught it in here. You can teach it with the buttons, you can teach it with an analog output. We have different videos on how to do that. But how does the wiring work? So now I take my output from my sensor, and it's going to just these flying leads. I have my power and my ground, so that is the brown goes to your positive voltage, the blue goes to ground. That's what I have here right now. I'm going to remove this clip. So now my sensor is working, it's powered up, it's functioning. But I want to look at the analog output. So the analog output right now that I'm using on this sensor, I told it to be current. I can also tell it to be voltage, but for current, which is more commonly used, I have the current come out of here, go through, and on your meter, make sure you take a look at setting it. Most of the time I'm using this voltage one here, ground and voltage, to do continuity tests, voltage tests. But for current, at least for my meter, I need to move it over here, and I'm going to put it into the milliamp setting because we're looking for 4 milliamps to 20 milliamps. Then that current has to go through here, get metered, get picked up, and come back through ground, which is why I have this basically connected back to ground. I'm seeing 18 milliamps. If I just move a route, I set myself up to a 1/2 meter as my 20 milliamp. And if we go past that distance in your PLC or whatever, you'll want to say, hey, if I ever go past 20, I'm out of range. Something has changed. And as I move closer and closer to my target, or for the sake of this, I will bring my target closer, and I'm going to get all the way down to 4 milliamps, and it will go below 4 milliamps. Again, you can use as an indication to say I am out of range. So it goes down to like 3.5 or so. That's really it. If I change this to voltage, it's really the same setup. Instead of now going through here and metering it, I would put this back over to the voltage side. Make sure I'm moving my meter to measure DC voltage, and I will now be able to measure the voltage. Right now it's not going to work right. I have this set up for current, and so it's going to give me some strange numbers, but I can set this up for 0 to 10 voltage output as well. That's all there is to it. When you move this to a PLC and you do programming, you need to scale that 4 to 20 to make it mean something for you. But as far as how this operates, it's really pretty simple. You just need those 3 wires: your power, your ground, your output, which goes back to that same blue ground wire. Thanks for joining us here on SICK Sensor Secrets. Stay tuned, like, subscribe, follow, comment. If you can on here, to just get conversations going on maybe what type of analog output you use, how you wire it, and how you set it up. See you next time.